Okay, so now we're actually going to get into calculating some of these transformations and doing the graphs. Okay, so what you've got to keep in mind is what I had written for you a while ago. Now, the only part that we're going to have here is going to be the A, of course I'll write cosine this time, and then BX, okay? Now that's just a portion of that formula that I had written down for you earlier. All right, so A stands for amplitude. So for this particular problem, the number that I have multiplied times my trig function here is going to be 2. So that's going to be my amplitude. Okay, period. Now I gave you a formula that said standard period divided by B. So we found out earlier that the standard period for cosine was 2 pi. So that means I have to have 2 pi, and I divide that by B. So what I have for this particular example is a 3. So that would be 2 pi divided by 3. Okay, reflection just requires that there were to be a negative sign directly in front of your amplitude, which I do not have a negative sign here. So this does not have the x-axis reflection. So just say none. Okay, now this is increment. So the formula I gave you for increment was period divided by 4. So my period is 2 pi divided by 3, but then I have to divide that by 4. So I'm going to put that over 1, and if you'll simplify that the way that we have simplified other complex fractions, you'll have 2 pi over 12, which will then reduce to be pi over 6. Okay, so we're doing our cosine graph. So here's going to be our y-axis, and we're just drawing just one cycle. So we're going to start our cycle at the y-axis and then go to the right. Now I know on my y-axis that I need to go up a distance of 2 because that's my amplitude. Because remember, amplitude is the distance from the x-axis up or the x-axis down. So that would be a distance of 2. Okay, this is where your increment is going to come in handy. Of course, you're starting at 0. Actually, 0 is your first increment. So then you're going to go a distance of pi over 2. I'm sorry, pi over 6. And then you're going to go another pi over 6. And then another pi over 6. So you're just adding pi over 6 each time. Now there's no, if you want to reduce these fractions as you make those, you can, but that's not something that's necessary. Now you'll notice that your last one here is 4 pi over 3. If you reduce 4 pi over 3, you notice you get 2 pi over 3, which is your period. But remember, period is the length of the cycle from where you start to where you stop. So since this is 2 pi over 3, then that should be what I have here. Okay, so you have to refer back to your cosine graph. All right, so let me lay this back up here. Of course, I had you to write this down. Now, I have different numbers on my tick marks here, but that's because all that I had in front of my x is just an understood 1, whereas the example that I'm working for you right now has a 3. So that causes your period to change, which then causes your tick marks to change. But what you need to notice here is the order or the pattern that you need to put your points in. So the point that's going to be on your y-axis is going to start up at whatever the amplitude happens to be. It's just here the amplitude was 1, because again here I have an understood 1. So the example I'm working, my first point's going to start up at 2, and then you hit x-axis, you dip down, x-axis, and come back up. So you just always have to follow that particular pattern. So we'll have a point here, and then the x-axis, and then it's going to dip down, x-axis, and then come back up. Now this is not a straight shot, this is not V-shaped, so you got to make sure you curve it so it's like you're coming down a hill, and then it's going to have the bowl-shaped part, which I call the valley, and then it's going to be like you're going back up a hill. So make sure you put the curvature to it. Okay, so there's the first example. All right, second example. Okay, so for this problem, Again, don't forget you have y equal a times cosine bx. Okay, so the amplitude that I have here is 1/2. Okay, so your formula for period is you have to do 2 pi divided by b. So 2 pi, and I'm going to put that that's understood to be over 1 because I'm fixing to divide it by b, which happens to be a fraction. And I'm putting it that way so then again I can use that method of simplifying that we've used the other times. So your 4 times your 2 pi is going to give you 8 pi. And then 1 times pi is pi, but then your pi's cancel and your period is just 8. This one still doesn't have the reflection, and I'll do one in just a second that does. But again, you'd have to have a negative sign directly in front of your amplitude. Okay, increment, you take your period, which we found to be 8, divide it by 4, so that reduces to be 2. Okay, so again, we're drawing just the one cycle, so we're going to start at the y-axis and go to the right. Now, my amplitude is 1/2, and I mean, just because it's 1/2 doesn't mean that you have to make it that distance little bitty. You know, you can put the tick marks as far apart as you want to put them. Just make sure that you label all of your tick marks. Okay, now, again, your first tick mark is going to be here at x equals 0. So your increment now tells you that you're going to go a distance of 2 for your next tick mark. So of course, I know 1 is in here, but we're not going to bother marking it. We're only going to mark the increments that we have every 2 units. So we're starting at 0, we go a distance of 2. And then another distance of 2, another distance of 2, and another distance of 2. So again, I'm ending at 8, which you notice matches up with your period. All right, you're actually going to put your points in exactly the same order that we did just a second ago because this is another cosine graph. So your cosine graph is going to start up here at your amplitude, x-axis, dip down, x-axis, and back up. So again, just make it curve as it goes around through these points. So that would be your graph for that one. Okay, one more example. Okay, now this time the only thing that's going to be different is us having to deal with the negative here. So if you remember and you look back at the definition for amplitude, it said absolute value of A, because the A value you have here is -2, but the absolute value of -2 is +2. Amplitude's always going to be positive. Okay, period. Now, even though I switched over to sine, your standard period for sine is still 2 pi. So you'd have 2 pi divided by 4, because that's my b, and that's going to reduce to be pi over 2. Now, since I do have the negative here with my amplitude, I do have x-axis reflection. So just write the word x-axis in the blank. Okay, do increment the same way as a while ago. Take your period, divide it by 4, which is understood to be over 1. So when you simplify this, you get pi over 8. Okay, so this graph that I gave you for sine, just that one cycle, started at the y-axis again and went to the right. We do amplitude the same way, so this time amplitude is 2, so I go up 2 and down 2. All right, this time my period is pi over 2. So again, we're starting at 0, so I go a distance of pi over 2. And now I add another pi over 2, and then another pi over 2, and another pi over 2. So if I reduce 4 pi over 2, then that's going to give me okay, I added the wrong thing. Okay, I'm sorry. I'm supposed to add pi over 8. I was adding pi over 2. Okay, so if I add pi over 8, okay, so this needs to be an 8. Pi over 8, and then I'd have 2 pi over 8, so we can fix this. And then 3 pi over 8, and then last 4 pi over 8, And then if you reduce 4 pi over 8, you get your 2 pi. Okay, I couldn't figure out what I had done wrong at first. Okay, sine graph. All right, so let me pull my sine graph back up. So this is what I gave you earlier for your sine graph. So again, you're going to follow this same pattern, but this time we have a reflection. If you were to take this point and reflect it around the x-axis, this point's not going to move, this point's not going to move, and this point's not going to move. But instead of this point at this tick mark going up to make your heel, it's going to have to come down because you have to reflect it across your x-axis. So if I didn't have the x-axis reflection, I would still make the heel first. But the x-axis reflection causes me to actually have to make the valley. So I would have to dip down first this time, then x-axis, then come up, and then x-axis. And again, just make sure that you curve. So you got your valley, and then you got your heel.